Hello, my name is Aseem Parikh and I am the VP of Solutions and Partnerships at ONF. I welcome you to another interesting talk at ONF's 5G Transformation Series in 2020. And I'm delighted to welcome our esteemed speaker, Prakash Siva, the head of hardware and cloud engineering at Radisys. Radisys is a valued ONF supply chain partner and a founding member of the ONF SDRAN project. In 2018, Radisys was acquired by Reliance Industries to push forward Reliance's Jio's 5G and IoT efforts, and as such, has a very good perch looking at the evolution of mobile networks. Prakash serves on the executive team at Radisys and brings 20 years of experience in sales, product, and engineering development to his role at Radisys. He is focused on enabling large communication service providers to adopt and deploy cloud, SDN, and NFV solutions using open source based products and technologies. Prakash also serves on the ONF's Technical Supplier Advisory Board, representing Radisys. Prior to joining Radisys, Prakash held management and engineering positions at HP, Turin, and Infinera. And Prakash holds an MS in electrical engineering from University of Texas at Austin. I invite Prakash to present his talk, and after which we will have a short Q&A discussion. Prakash, welcome, and please take the floor.
Thank you, Aseem. Really appreciate this opportunity to work closely with ONF and the broader community on this really exciting project, SDRAN, Software Defined RAN. So let me go ahead and share my screen. Today we're going to be talking about SDRAN, lots of focus on the open source RIC, the xApps that go along with it, and really integration with the Radisys DU and CU. A little bit of an overview of our Connect OpenRAN portfolio. We'll talk about Connect OpenRAN, then we'll go into a little bit of the architecture. We'll talk about why Radisys wants to join the SDRAN project, and we'll finish up with some of the cloud aspects, and also not just the near real-time RIC. We'll also talk about the non-real-time RIC, the AI ML aspects, and what that brings to the table. Connect OpenRAN. This is the heart of this is really a software and a disaggregated ecosystem that is tied to an open framework. So what we are trying to here is to integrate that disaggregated ecosystem with a lot of open source and Radisys software. The software has a background in being proven. It's globally deployed. We have the scale and expertise, a significant number of 4G, 5G R&D experts in software and professional services. As you have might know from our work before, we have significant brand leadership in a number of communities. We'll talk about ORAN, talk about OTIC, we'll talk about ONF, and of course STIP. Open contributions, we have made a number of contributions to ORAN, the ORAN Alliance, STIP, and certainly ONF. So if you look at Connect OpenRAN software, three major blocks: the protocol software itself, reference implementation, and really the packaging of the protocol and the reference implementation to build open source based eNode BG node piece. A little bit of our history and portfolio. We've had significant experience going back, and we support 3G, 4G, 5G NR certainly, and MEC workloads today as part of this overall product portfolio. A little bit about our telco ecosystem contributions. Radisys has had significant contributions to all these communities that you see over here, starting from the left, ORAN, and before that when it was xRAN. We've been involved with the API development, joint solutions with Intel, working group participation. I'll go into that a little bit more. Design and specification contributions. Certainly on the ONF side, we value our partnership with ONF and the entire community. As Aseem mentioned, we are members of TSAB and ESAB. We have made some significant contributions to SIBA and Volta architectures which have tried to bring open source technologies to the broadband space. And certainly we have worked on the exemplar frameworks and solution integration. Radisys has also been involved with the Small Cell Forum. We are a contributor member. We have contributed deeply for the NFAPI, the FAPI, for folks who are aware of this, the MAC-PHY interface. We've been deeply involved in that. We are also an observer member at CBRS. We'll talk more about CBRS and where that fits into the overall ecosystem and architecture. We are part of TIP. We are a TIP Type 1 solution integrator. We have contributed both the contribution on the LTE and the EPC side to TIP, development for Open Cellular and OpenRAN. We have also performed integration for TIP demos at the TIP Summit and MWC. Radisys is also certainly involved in 3GPP. And so the complete set of ecosystems that we are involved in is the basis of our further going forward with the SDRAN. Before we go to SDRAN, I wanted to quickly talk about our ORAN leadership and contributions. And this is, in our view, is clearly aligned with SDRAN. We've taken active leadership in a number of working groups listed on the left, WG8, along with we have the co-chair with Intel, AT&T, and China Mobile, and the leader of the TG2 and the TG4 task groups. We have the project technical lead and for the ODU High project on the ORAN software community. And certainly we have deep competence in the ODU architecture, given our background in both the protocols and systems. We also had, on the left side is leadership, right side is strong contributions to WG3, the RIC architecture, WG5, we are the liaison from the Small Cell Forum, WG6, we have contributed with Sienna on ORAN edge optimization and orchestration, and certainly in WG7, we have submitted the industry first ORU reference design white paper. So Radisys is a rich history of both RAN, protocols and protocol stacks, along with ecosystem leadership. Let's talk a little bit about SDRAN contributions, our contributions to SDRAN, and why contribute to SDRAN. The picture on the left is certainly from SDRAN. SDRAN represents the next evolution of the RAN space to build an open source RAN that uses the micro ONAS as the near real-time RIC with xApps running on top. And of course, interfaces E2 towards the CUDU and A1 towards the non-real-time RIC. As we see this, we see SDRAN augmenting our leadership and our capabilities in design and deployment of next generation RAN. The focus on COTS hardware, the focus on disaggregation, multi-vendor orchestration, and cloud infrastructure are all required, we believe, for success of next generation RAN. The support for disaggregation via ORAN and the 3GPP split options, extremely key. 7.2 options. The fact that it's software defined. Micro ONAS is the evolution of the ONAS SDN controller, can be used in a cloud native environment, and having the RAN programmable via the near RT RIC that's built on top of ONAS is key for this whole effort. SDRAN also, we believe, enables flexible and advanced RAN operations. This includes both the efficient orchestration and network automation. Network automation is going to be key for 5G, both from a OpEx point of view, as well as speed and time to market point of view. And certainly, we see deployment models across tower, edge, and regional data centers. The other key reason why we believe SDRAN is important is and Radisys is contributing, is the rapid innovation via xApps. Radio resource management functions, advanced RAN control capabilities, whether it is radio optimization, observability, pre-quarter capabilities, channel prediction, all of these we believe are valuable xApps that can be run on top of micro ONAS and the near real-time RIC. And that brings in what we believe this will drive is rapid innovation. Finally, interfaces to the non-RT RIC. Interfaces to the non-RT RIC or the A1 interface are also key, where we believe the use of AI ML and really inferencing to support areas like RAN slicing for both service assurance and KPI targets is extremely important. So it's not just the near real-time RIC, but having the right northbound interfaces for the non-RT RIC is fundamental to what we believe is the automation and the use of AI technologies with 5G networks. A little bit into our architecture, what we are doing. This is an overview of the different split options. If we focus on the middle set, which is really the xRAN or the ORAN split options, we see 3 blocks here: DU, RU, and CU. DU is all in green, RU in blue, and CU in pink. Most of the software in green and the pink, the CU and the DU, come from Radisys. There are parts of these that will run on accelerated hardware. We'll come to that in a second. But we should think of this as an open system that allows us to plug in different CUs and DUs. Of course, we will interoperate with third-party CUs and DUs. Radisys is bringing the green and blue blocks to the table. If we talk about the cloud-native DU and CU architecture, all the components that you see over here in the middle block, both the control plane for the CU, the data plane, along with the DU, the ODU shown in the middle, all of them can be cloudified. It either runs on bare metal or in cloud-native architecture. We have looked at and we execute our software on a number of cloud-native platforms. When you talk about the ORAN cloud architecture, we have to dig in a little bit deeper, and where we see tremendous source of both innovation and cloud-native capabilities is having the right cloud-native platform. So if you break the platform down, you can have cloud platform management as well as the cloud platform runtime. Cloud platform management includes node feature management, configuration management, user management, a whole set of capabilities, including HA and faults. Cloud platform runtime includes support for accelerated drivers for the edge cloud. And we have to talk about a little bit about the hardware accelerators. Some of the key capabilities like FEC, encoding, decoding, will depend upon the use of external FPGAs outside an x86 platform, for example. And the right drivers are equipped for that. Same for the network drivers, board management, PTP, support for 8275.1 and .2 profiles. All of these are part of the cloud platform. We do support multiple ODU deployment models. ORAN mentions flat, hierarchical, and hybrid models. Current focus is on hierarchical and hybrid. In terms of cloud deployment models, we see ODU or ORU at the cell site or ODU at the edge site, as shown in the figure below. A little bit of the use cases and the use of the E2 interface. ORAN defines a number of use cases: traffic steering, QoE, QoS-based resource optimization, and context-based dynamic handover, for example, for V2X. The picture on the right is for the traffic steering use case, and this includes a combination of interfaces, both O1 as well as E2, and we expect to support third-party SMOs, but we expect to have a default SMO and support multiple third-party SMOs as part of these use cases. In terms of the E2 interface functions, E2 AP is an important aspect here. E2 functions are grouped typically into 2 categories: near RT RIC services and support functions. We expect to support for the near RT RIC, of course, with the micro ONAS, report, insert, control, and policy services. And the support functions include interface management, service updates, and so forth. All of this is expected to be running as part of the ODU and the OCU functions that is supplied by Radisys. Finally, let's talk a little bit about the control loops and the RAN intelligent controllers. There's two types of controllers here, micro ONAS for the near real time and non-RT RIC for more what we think of as control over longer timescales. So if you look on the left, things in the order of 10 to tens of milliseconds is typically what we think about at the lower levels. Certainly sub-second in the middle, and a second or higher at the highest level. And the non-real-time RIC has is focused on service and policy management, lots of RAN analytics, and inferencing and model training. Where we see this useful is we see two classes of applications in the non-real-time RIC. One is controlling the runtime aspects of the RAN, and the other is looking at the RAN capabilities or RAN characteristics at longer timescales and helping the operator make intelligent decisions about the use of or intelligent decisions about the configuration and the use of the RAN at either at certain points in time, depending upon the certain times of the day. It can be time of the day. It can be based on time. It can be based on location. All of those where we want to extract more value from RAN information over longer timescales. We see the use of the non-real-time RIC, and certainly the presence of the A1 interface is key. And Radisys expects to use both the real-time and the non-real-time RIC as part of our overall system. Thank you for the opportunity to present our CUDU as contributions in binary form for the SDRAN product. SDRAN project. This is an important project that attempts to move forward an ecosystem, and the combination of both ONF as well as ORAN capabilities is both interesting and important for Radisys. Thank you.
Thank you very much, Prakash. Wonderful job. Good job. And overall, I'm very excited to see the Radisys contributions to SDRAN, and the work you are doing and the work the community will do on top of SDRAN with these contributions would be very interesting and kind of really usher in the new era of open 5G. So I'm excited and thank you for that.
Absolutely. The new era of 5G with the CARTs, with disaggregation, with open software, all that coming together is really exciting.
Great. Now, so I do want to double click on a couple of areas to kind of start off our discussion, and then we'll see where it goes. I think in the beginning you mentioned Radisys being pretty active in a lot of open source consortia and organizations, and specifically ORAN Alliance, TIP, CRS Alliance, and others. And you talked about how actively you're leading and contributing to ORAN and the OSC. I want to kind of help us draw a line through these different organizations' activities and see how synergistically these organizations kind of allow you to stitch up end-to-end disaggregated and open RAN solution.
Sure. I think you bring up three very key ecosystems. Of course, from our point of view, ONF is key, but let's compare a little bit between, I think you brought up ORAN, you brought up TIP, and let's say, I think we talked about CBRS. Folks know about what ONF brings to the table. We've been deeply involved. ORAN certainly focus on standards, and we almost think of this as a union of operator needs across the spectrum for the next generation RAN, and to be able to support the right 3GPP split options and so forth. TIP is slightly different, less focused on standards, but focus on the overall platform, and with the focus on the marketplace, where people can look at and select products from that marketplace, and sort of a broad ecosystem that includes both developing and developed countries in terms of cost profiles and so forth. And last is CBRS, certainly US focused, but other countries are also setting aside spectrum for similar kinds of capabilities, and a little bit more standards, more architecture to be able to put together a CBSD for these types of networks with SaaS and that entire ecosystem. So what we see is we are pulling together the best of these three worlds and understanding how we can put together systems that allow us to meet these broader goals. Each of this has a place to play. The union of operator needs is extremely important so that we don't get fragmented. So we don't do things just for a very small set. At the same time, we also want to be very broad. We want to be able to address different markets. And those markets can be both wide in terms of geography, and that would be, like I previously said, developed countries, or it can be also private and public networks. That is another way to slice. So what we see is that broadness is what we want to address, and we are addressing with our OCU or ODU. So in that sense, we pull together from all those ecosystems that you mentioned, Aseem.
No, wonderful. Now, I surely want to come back to the private market, but let's stick to the kind of the public mobile networks, kind of
Sure.
large tier 1 mobile networks. And in that space, I'm trying to understand that, obviously there's a current way of architecting those things with, proprietary systems and radios and all of that. But in this kind of new world with micro-ONOS based RIC and xApps and, the Radisys, RU, DU, CU, when can we see the first kind of end-to-end POC solution, and what are the RU options which Radisys would support on top of your OCU and ODU?
So that's a really good question. I think the key words there are when can we quickly see? I think the word POC, I think you mentioned, end to end, right? I think let's start with end to end for a second. I think the fact we are bringing together a near real-time RIC, that we are bringing together an OCU and ODU, I think, of course, RU has to be there. That is a fantastic start. But there are, I believe, we believe there is more that's needed. And some of the other pieces that are needed is, one I mentioned is an ORU. And to have the right ORU partners, and we'll talk about this more when we discuss the OTIC, is to have the right ORU partners, and to ease integration is key. So that's one part. And of course, given this is 5G and based on ORAN, we see support for eCPRI as mandatory. The support for ORAN front-haul interfaces is mandatory. We see ORUs can be of multiple types. This is what's called type A versus type B, depending on whether pre-coding happens on the ODU or it happens on the ORU. We are starting with a type A ORU, but we will move to a type B ORU at higher layers and at higher antenna transmit and receive points in time. So we will start with a certain set of ORUs, but we also realize that there are other components that are needed for the end-to-end. And that includes, for example, NGC components. We've talked, it's not, here we're talking about, we have to talk about whether it's SA or NSA. And even if we go with the SA approach, that still requires NGC components, the UPF, AMF, SMF, and a number of others, especially more like a PCF if you want to set policy. Maybe not needed for a POC, but still from an end-to-end perspective, a UPF would be required. So NGC components. And the last thing we shouldn't forget is the SMO, the orchestrator that pulls all this together from an end-to-end perspective. So what we think is, assuming all this comes together in a reasonable amount of time, we think that think of 2 quarters, think of months, those kinds of time frames where you can put together a basic system, assuming those components we talked about beyond the CUDU are available.
So I'll do a shameless plug for the Ether platform, which has some of the components you're talking about.
Absolutely.
Right. So and we'll talk about that in a different context, but UPF and things like that are also being developed within the ONF community, as you know. So
correct. UPF and the OWAN interface, the management interface is key, right? To have that, and having the SMO is the other part of this.
Wonderful. No, so now, let's get, you said a couple of quarters to get to the POC where you can see the whole thing live in action and do at least
a basic
basic data from a UE
yeah.
all the way to the core and show the power of this SDRAN in action. The question is, what would it take to now convert that into a real field trial deployable solution, right? At a telco, and especially given Radisys is kind of, that's been your business line for you. What kind of engineering effort are you planning to throw at this problem in that time frame, in the next 12 months, 18-month time frame?
Absolutely, I think it's so to move from POC to field trial and a complete deployment requires what we believe is focus on 2 or 3 key items. Some of this we have talked about. One is the manageability aspects, both the FCAP side as well as the overall orchestration and automation. And given that we are talking about a cloud native platform, the other important part is a CI/CD pipeline, so that changes can be rapidly, how do I say this, accommodated as part of the overall process. The other important thing is we haven't talked about xApps yet, and we need to come to that part. Even in the previous question, that's the other thing that would be needed, and we'll come to the xApps in a second. But in terms of manageability, on the OWAN interface needs to be well defined. The data models for DU and CU are work in progress, so those would need to be completed. And the other thing we need to talk about is scale, right? It's one thing to be able to show a few UEs, the other things to be able to hear. We're talking, the DU we're talking about is, let's say, about 100 megahertz. We're talking about N78 bands. We're talking about 256 QAM. We're talking multiple hundreds of UEs, right? And so all of this, and this is on a per sector basis, we're talking about per competent carrier. All of this needs to be pulled together in a comprehensive orchestration framework, and that is important, along with the cloud aspects that I previously mentioned. Those are, again, incredibly, those are table stakes as part of for field deployment. So we haven't talked about xApps much, but I think other thing that's extremely going to be important is the selection of the right set of xApps. Mm-hmm. So this here, we could go, if you break the whole xApps ecosystem down, or if you put it in different buckets, you could think of this as service analytics, you could think of this as RAN analytics, service optimization, RAN optimization. So one important decision that, or maybe the community has to come up with after discussion is, what would be the set of simple xApps that would be used initially? Is it for observability? Is it for selecting precoder, for selecting, I mean, there's a whole range of capabilities here for the xApps to be made available, valuable for the ecosystem. But the choice of xApps is also important, we believe, to get something towards rapid deployment.
No, I think xApps are going to become a very important kind of criteria for success of this whole project, right? If we don't bring the right intelligence and don't make that available directly where it needs to be, with sitting right on top of the micro ONOS kind of near real-time RIC, some of the capabilities which 5G needs from,
correct. It is what it needs, and how do you bring innovation into the RAN ecosystem? How do you control, and how are you able to place that in a multi-vendor environment where third parties can bring in xApps, yet not be burdened with integrating with every DU and CU, right? It's both the innovation and the speed of that innovation that xApps bring to the table. That's important.
So you mentioned OTIC, the Open Test and Integration Center, which I think ORAN and TIP jointly announced. Are you planning to leverage that for some of these scalability and testing of different xApps and things like that? Is that how?
Absolutely. Radisys has been present in the in the first OTIC Blockfest in 2019. And we are certainly going to attend the one coming up in September. It's coming up this month. So this is an important area where one is the standards. Of course, that's important. The other is the software to be able to support those standards, but having a framework where we can test against our partners and potentially a range of partners in an open environment is key. And in that sense, OT and what OT brings to the table we think is extremely important. The other part here is given that we are part of both ORAN as well as the TIP ecosystems, and of course ONF and so forth. We believe that that combination is must have. That is, we need to, and we will participate in as part of the OT coming up in September.
Very good. All right, so let's talk about the other potential opportunity you mentioned. This is the private enterprise private networks leveraging 5G, 4G connectivity solutions, right? So, and CBRS in the US, and you mentioned that other countries and other geographies have their own lightly licensed spectrum being made available so that enterprises can use 3GPP technologies like they use Wi-Fi technologies today pretty easily. So what is your view on this opportunity, and how do you think who would be the best suited to take this kind of technology to the enterprise in the private 4G, 5G solution space?
So this is again an excellent question. We see the use of 5G technologies for what we think of as more than telco and operator environments is to be incredibly important, both to grow the overall industry from where, and we mean in terms of the applicability of 5G, both from a technology and from a revenue standpoint, right? I think both are equally important. If you think of CBRS in the US, and there are other countries worldwide, for example, Germany, I know, set aside spectrum. There are other countries that set aside spectrum. That is a direction that we need to move towards. But we also need to be cognizant of enterprise workloads, if you want to call it so, RAN as an enterprise workload, requires a significant level of, how do I say this, simplification and packaging to address those needs. Given the telco needs are to optimize the RAN on many conditions, the enterprise might be, the vertical might not have all those different conditions in place, right? So for example, we talked about tower bottom, we talked about an edge data center, we talked about a regional data center, a centralized data center. We might not have that many deployment locations, for example, right, in a private space. It might be a vertical in a certain location, it might be a factory, it might be a hospital. So there are some simplifications we believe are absolutely needed. But the fact that the overall system is disaggregated is a huge advantage, because then you can use that disaggregation to bring in the simplification that is needed with the right features for each of these verticals. Certainly ONF Ether project has, we have looked at that, and other people have looked at it, and it's a fantastic effort. But there are also others. For example, Intel has openness and SERA, converged edge architectures. So I believe it will be a combination of these that will, there will be no one winner, but the underlying disaggregation, right, the underlying capabilities will enable 5G to meet private and enterprise needs, communication needs. That we believe will happen. And having something like what we're doing with SDRAN moves things forward, because it again gives us a forum and a platform to enable these things to occur.
No, and given the activity in that space, I'm just amazed that I think I've seen everyone from startups to cloud operators to telco operators all wanting to kind of make inroads in that enterprise 5G, 4G space. And technical solutions are like you said, Ether and openness and others would come together, and maybe people will pick the best of each and bring up a commercial solution. Question is, from your view, and again, this is just a hypothetical question, who would be the best suited to kind of address that? Would it be the customer, like operators who already have those enterprise customers as their current customers? Would it be a new entrant in the market? Would it be a more telco focused, a Zoom, a video kind of company coming into bear and taking out the people who have been traditionally providing, communication services to enterprises?
I see. I mean, of course, telcos have and continue to serve enterprises. I mean, that is a key market for them. But we also see lots of ability to address verticals is required. And when we think of verticals, we think of deep domain expertise to understand the pros and cons of solutions and the packaging of those solutions that is usable quickly by an IT department, right? To fundamentally think of an enterprise IT department being able to deploy. So it's going to be a combination of telcos, certainly operators, but it's also going to involve some system integrators, we believe, in vertical domains who have deep expertise, vertical expertise in those domains. And I think the key there is really simplification. While a lot of things can be done to pick the right use case for that domain and marry that with the technologies, 5G technologies, whether it is eMBB, whether it's URLLC, but to really make connectivity as a service, connectivity as a deployable service in a cloud native way, whoever does that, and we believe both the operators and the system integrators have part to play, that will be the solution that wins. And it will be, we believe that will be different across different verticals. But there is incredible opportunity here to innovate and to move the whole industry forward.
No, I couldn't agree more. No, we're patiently looking at the market 18 months out, and we are going to see some winners already emerge at that time, I expect. So before I let you go, I think we are we have a couple of minutes. The last question, and I suppose being part of the Reliance family, I suspect you would be expecting this question. So does Jio plan to use the Radisys Connect Open RAN stack? Can you say anything about it? I'm not asking you to make any announcements.
Good, again, Aseem, let me, I would say this, that Radisys and Jio are part of the same group in Reliance Industries, right? Reliance is the overall parent, and both Jio and Radisys are part of the same group. And there's lots of factors, lots of stakeholders in making these decisions. And the products and capabilities that we are building are certainly Jio's a customer, but we want to make sure that these are globally applicable, right? That is, the capabilities are global, or the capabilities that the products we put on the table address global needs. That is fundamental. That is the basis of what we have developed and continue to develop. I'll just leave it at that.
No, I'm sure Jio, if I was sitting on the Jio side, I would also expect that any vendor I choose is also, building products with which are applicable and work anywhere else in the world, because I don't think Jio is maybe very centric to only India or only one geography, right? They might have aspirations to grow that network beyond and potentially possible. So any other operators you can name that you have started dialogues with yet, or are you hopeful of?
We are quite hopeful. We're excited by the opportunity that in front of us. Historically, RAN has been one of the change in RAN has come slowly, but we see that accelerating. And this is an important juncture and an important point for that acceleration to take off. So yes, we are talking to a number of operators worldwide, and yet we're excited to be part of this opportunity.
Great, Prakash. Again, thank you very much for your talk, and it was a very informative talk, and I enjoyed this discussion as well. I also want to thank our viewers for their time and suggest that you check out other interesting talks and conversations in the Spotlight series. Have a great rest of your day. Goodbye.
Thank you. Thanks, Aseem, and thanks, ONF. Take care, guys. Bye.